Where do waves come from? Is our planet getting warmer? Can a sinking treasure house be saved? Seemingly unconnected, these are but a few of the questions that have challenged the restless mind of a remarkable man, oceanographer Walter Munk.
I have become interested in problems that other people consider noise or garbage. People said, well, that's experimental error, that's garbage, that's noise. But eventually, in my case, turned out into the most interesting problem. And so one man's noise is another man's signal. And if you find that the noise has some interesting geophysical origin, you might learn something very interesting. And I suddenly plead guilty to having done so.
Although he is virtually unknown to the public, Walter Munk's provocative ideas stimulate scientists around the world and may eventually affect us all. For over 50 years, he has studied and worked at Scripps Institution of Oceanography, part of the University of California, San Diego. He's a major player in world-class science, his giant intellect leavened by a touch of the pixie and old-world charm.
People will be able to adopt. But
responding to a friend's request, Dr. Munk meets with a group of school children visiting the new Scripps Aquarium.
Lower than 4 or 5 feet.
If you keep your ears open, he says, you can learn more from students than they will get from you.
Do you think in our lifetime that global warming could become a big problem?
You see, that's the political argument. Should we go and spend a lot of money now? Because you don't know for sure what's going to happen. And I myself think that it's too early to really spend a lot of money doing that. I think one ought to do some good observations, like what we're doing, see whether the oceans are getting warmer, and wait until the evidence is really very clear-cut.
Was there anything that made you decide you wanted to be an oceanographer?
You want me to tell you the truth? I was at school in Pasadena and I had a girlfriend in La Jolla. And it's the only way I could afford to come here was to get a job at Scripps. So that's how I first started to be an oceanographer. So it wasn't a very profound decision. It was just kind of a convenient thing to do. I hope you have better reasons to choose your profession than I did.
The oldest oceanographic institution in America, Scripps was a small and isolated research facility in the late 1930s. For a time, the fun-loving young man from Austria was the only student in his field, geophysics. Later, Walter would call a youthful escapade his first oceanographic outing. After service in the U.S. Army, ex-Corporal Munk returned to Scripps and began a long association with the Navy. As America mobilized for total war after Pearl Harbor, Munk and a small group of oceanographers worked on plans for Allied landings in North Africa. They learned that landing craft were likely to capsize if waves reached a height of 6 feet.
I then looked at the climatology of waves at the landing beaches and found that during the winter months, the landing was a winter landing, they exceeded 6 feet in 2 out of 3 days. And I thought this was a catastrophe in the making. There had never been an attempt to predict waves. So the only way out was really to try and make a prediction and pick a couple of good days to get in. And I worked for a while alone on trying to use weather maps to predict the generation of waves and then predict the decay away from the storm areas. and finally the transformation of waves as they come into shallow water. And then asked Harold Sverdrup, who was here at Scripps, whether he would come for a month and work with me. And so we worked together for a long time on this, and we did make a prediction for the landing beaches in Northwest Africa, which turned out really rather well.
2 years later, when Allied troops prepared to invade Europe, the Sverdrup-Monk theory and methods for predicting waves would be crucial to General Eisenhower's fateful decision for D-Day, 6th of June, 1944. Countless lives, and indeed the course of history, affected in no small measure by the pioneering work of a 27-year-old graduate student and his mentor. Asked by a child to describe his job, Monk once said, "I have fun trying to learn something about the oceans." Alert and vigorous at 76, he's still having fun. Although he appreciates the advantages of modern technologies, Monk retains fond memories of times when he and colleagues would spend months at sea. During an extended expedition in the Pacific, he learned scuba diving, using the primitive equipment of the early 50s. For geophysics, at least, Monk sees little to be gained from diving. In general, he says, you're better off putting down instruments than putting yourself down. Today, with jet planes and instant communications, time at sea is brief. He misses the extended contemplation afforded on a long voyage. Monk's pride and joy is IGPP, the Institute of Geophysics and Planetary Physics, which he founded at Scripps in 1960. Housed in a building influenced by his architect wife, Judith, IGPP has achieved worldwide recognition. Three decades ago, as today, Walter Monk looked out at the sea and asked questions. Questions about the long rollers that delight surfers in California and Hawaii in summer. Where do they originate? Can they be predicted? Personal observation and scrutiny of aerial photos led Monk to infer that the waves must come from far away, the effects of winter storms in the southern hemisphere, some 5,000 nautical miles distant. He asked his colleagues, could ocean swell tell us about distant storms? Could we identify a train of waves clear across the Pacific to Alaska? They organized a major expedition. Frank Snodgrass developed equipment that could measure waves a mile long and only 1/10 of a millimeter high. 6 teams would spread out across the Pacific from south to north. Antarctic storms had begun when expedition members reached their assigned positions. Waves from the first storm hit New Zealand just 1 day after the Scripps crew completed their installation. Next in the long chain of monitoring stations, Samoa, 2,000 miles away. Monk and his crew had to run a cable from a nearby village to an isolated point at water's edge. For the next 2 months, the cable would undergo constant pounding of waves and rocks. At the end of the cable, beyond the breakers, a wave sensor was lowered to the ocean floor.
We lived there for 3 months and took records in a little remote village with no electric power, no plumbing. We took a generator along and we had to charge the batteries with our generator, and that worked out all right. I think we spent more time fixing the generator than we did doing anything else, but it's an example of oceanography as it really goes. My children were very young then. I think they were 3 and 5. And we lived in this village and had an absolutely wonderful time.
6 hours every day, the teams recorded wave activity, compiling mounds of data. Soon, Monk realized they could predict the arrival of waves at other stations. The low-lying atoll of Palmyra was next, 1,600 miles north of Samoa. Another 1,000 miles north, Hawaii served as a recording site and headquarters for the expedition. 2,000 miles farther along the Great Circle route, in the cold waters of the northern Pacific, a unique vessel took over. The floating instrument platform, FLIP, turns on its end by flooding its ballast tanks. With all but 55 of its 350-foot length underwater, FLIP barely moves in the waves, providing extraordinary stability for recording instruments. 30 years later, FLIP is still in active service with the Scripps fleet.
It took about 2 weeks for the disturbance to go from an Antarctic storm to Alaska. By the time it got to Alaska, of course, the waves were very weak, very, very low, but could still be recorded. The shape of waves move, not the water itself. It's like if you take a carpet and you shake the end of it, you can make waves go down the carpet, but the carpet itself remains fixed. So it's the energy associated with the disturbance which propagates through the wave disturbance and can be followed, which is what we did during that expedition, can be followed successfully halfway around the world.
Over the years, the U.S. Navy has honored Monk's work, much of it still classified. He says only that some of his efforts involve submarines. In further tribute, the Navy has established the Walter Monk Award for Excellence in Ocean Science Research, a medal designed by Judith Monk.
Ladies and gentlemen, the President of the United States and the Vice President.
In 1985, Dr. Monk joined an elite group at the White House to receive the country's highest scientific honor.
Today is the day for the National Medal of Science. And now I know Einstein once remarked that the whole of science is nothing more than a refinement of everyday thinking. Each of you has devoted your energies not to truth as understood, but to the search for truth not yet understood. You had faith that you'd come to understand the unknown, and you did.
Walter H. Monk, for his unique contributions to geophysics and physical oceanography.
A proud moment. As at most grand occasions, Walter wore his trademark knee breeches. This photo holds a special place in the Monk's family album. Walter and Judith Monk travel widely. Member of the National Academy of Sciences and Britain's Royal Society, Walter is in frequent demand as lecturer or consultant. He makes no distinction between work and play.
Venice is an example of how things go differently than what you expect. I had been invited to go there to think about a problem that the Italians call acqua alta, high water. Storms which raise the Adriatic sea level and eventually produce a flood into Venice Lagoon.
Wind-whipped seas lash Venice, paralyze gondola traffic, and leave famed St. Mark's Square underwater. Despite repeated flooding, ancient Venice remains a romantic treasure house of history and art. Over centuries, gradually rising sea level has exacerbated damage from floods. Monk conceived ways to predict tidal surges. His work in the early 1970s was essential to the city's long-range flood control scheme. Construction of movable barriers, or gates, across the 3 inlets connecting Venice Lagoon with the Adriatic Sea. 2 decades later, the plan is still mired in bureaucratic wrangling. Many fear that closing the gates would worsen the already severe pollution.
It occurred to us that you might be able to solve another problem, which is the very bad pollution inside the lagoon. Right now, the water just comes in and out. And I've seen the same piece of disgusting stuff through many tidal cycles, not really getting lost, just going in and out and in and out again.
Monk offers an ingenious proposal. Open the Lido gate at rising tide, closing the other 2. At high tide, close Lido and open Chioggia, thus forcing a circular motion to flush out the polluted waters.
I think it is an idea that would in fact lead to a significant improvement of the quality of the water. And we have a good way of describing that by a slogan, "Let the moon flush the lagoon." It rhymes, and it rhymes even in Italian.
In New York, at Columbia University, a black tie event added to Walter Monk's long list of honors. His choice of formal attire did not go unnoticed.
And look at my, Judy got me those breeches. And that is what I wore when I met President Reagan. He looked down at this before he gave me my medal.
And the trustees of the G. Unger Vetlesen Foundation, it is a great honor and privilege to present this check and the 1993 Vetlesen Prize to Dr. Walter H. Monk. Thank you.
Given for outstanding achievement in the sciences, resulting in a clearer understanding of the Earth. The Vetlesen Prize, obscure yet prestigious, awards a gold medal and a check for $50,000.
Thank you very much. The ocean is an important component of the atmosphere-ocean heat machine. There's a great deal of interest, as you all know, in whether there is warming taking place as a result of the emission of greenhouse gases. And yet, there have been no measurements as to whether the ocean today is actually warming, only speculation.
To replace speculation with fact, Monk proposes to measure the speed of sound through the oceans. Sound travels faster through water than through air, faster in warm water than cold.
The first question to be answered was whether you can measure the speed of sound with sufficient accuracy to be able to note whether the oceans are changing their mean temperature or not. And that means generally to measure to an accuracy of 100ths of a second.
For a feasibility test, Monk chose Heard Island, a barren volcanic rock between Australia and Antarctica. From here, he can radiate sound signals into all 3 ocean basins, reaching both coasts of North America simultaneously in about 3.5 hours. In Monk's mind, the idea is simple. Meticulous recording, over years, of the time it takes for sound to travel known distances will reveal if the oceans are getting warmer. If ocean temperatures are rising, the Earth too is heating up. Large transducers, underwater loudspeakers supplied by the Navy, will transmit computer-generated sounds. The test makes use of a natural phenomenon of the sea. At an average 1,000 meters below the surface, a sound channel traps and confines acoustic energy, enabling sound to travel enormous distances. Supported largely by the U.S. Office of Naval Research, the experiment was an international effort. In all, 10 countries set up stations to listen for the coded signals from Heard Island.
I had sort of lived that day for 2 years before it started. What would it be like? Would we be heard at all? We really didn't know whether man-made acoustic instruments of this kind would be loud enough that they would be received at these large distances. Different theories gave conflicting answers. Just before the 0 hour, the people aboard the ship asked whether they could check the equipment, which was normal, turn it on for just 5 minutes to see whether the acoustic sources were working. And I said, yes, of course. I had gone to sleep when we received a very puzzled fax from Bermuda saying, we picked you up, and what in the hell are you doing? You're not supposed to start until tomorrow morning. And I thought, oh, that is just wonderful. That question has been answered.
5 days into the experiment, a fierce storm hit Heard Island. Thirty-foot waves rocked the ships and damaged all the underwater speakers. Although forced to abort the operation, Monk is confident that enough information got through to call it a success. He said, "We learned what we had to learn."
But I've always thought back as to what would have happened if the storm had happened on the first day and we would have lost our equipment. I'm absolutely sure that we wouldn't have been given another chance. It was expensive, and people wouldn't have supported us for a second try. And that brings me to the most important ingredient in a career as oceanographers. You have to have some luck, or you're just not going to make it.
What Walter Monk calls luck, others may call talent and hard work. He's written some 200 scientific papers, been honored by academies and universities around the world. Although officially retired from the University of California, San Diego, he works on as intensely as ever, in a post endowed in his honor by the U.S. Navy. At age 76, he's moving ahead with a 10-year project to test global warming by measuring the speed of sound through oceans around the world. And he delights in dropping in on younger colleagues to keep in touch with new research and new ideas.
I have found it very exciting in the past when some new technology was developed to learn how it would be useful. And I have the basic conviction that most of the progress that's been done in oceanography was the result of applying some new technology, not because somebody had some great new ideas. But a new technology almost always leads to a new understanding. I think it's a perfectly good way to go.
Dr. Monk, would you like the fun job?
Yes! What's the fun job? Oh, hold on to that?
Yeah, but don't pull it.
Don't pull because...
Oh, that's it.
Snap it.
All right, I better get rid of my coffee. I'm not a good seagoing experimentalist. I love to go to sea, but my students and associates who go to sea with me very carefully keep me away from any pieces of gear, because if I see a switch, I find myself seeing what happens if I turn it, and that can be fatal. So I'm usually placed in a position which is less likely to interfere with the experiments. I see. It doesn't go very much deeper.
Pull it.
I see. There we go.
Just one meter.
People say it's being the garbage man, you know, starting something and introducing the subject and making all sorts of unwanted assumptions and getting everybody very upset. But eventually I think you serve a useful purpose. The reason it's a spiral is that as you go deeper, you see the scatter further out.
What you're doing is you just have this little
I prefer that mode of operation to writing a final monograph on the subject. I think asking the questions at the right time is as important a contribution than giving the answers. And I would like to think so because I've been much better asking questions than giving answers. I'm not a good theoretician. I'm certainly not a mathematician in the sense that a mathematician would use. This is not false modesty. I've had fairly decent ideas about what might be some important question to work on. And I've had considerable luck, I think, in choosing subjects which at the time were not popular, and then in 10 years or so did become popular. And then when too much was written about it and you had to read too many papers, I'd try and think of something else to do. Yes, I have great fun in my job. I think I have the world's best job. And I pretty well do what I really want to do and get paid for it.